Study Section 2. Presentation of Data. Introduction. The aim of this study session is to introduce the various methods of presenting statistical data. Presentation of data in tables, charts, and diagrams facilitates understanding of the important feature of the data. Learning outcomes for Study Section 2. When you have studied this session, you should be able to explain the various ways of presenting a mass of data, construct a frequency table, explain and carry out simple descriptive analysis of data in tables and diagrams. Ways of presenting a mass of data. Numerical information data about the characteristics of a variable when collected is often massive and complex. More often than not, it is necessary to present data in tables, charts, and diagrams in order to have a clear understanding of the data and to illustrate the relationship existing between the variables being examined. We shall discuss the frequency table, cumulative frequency table, stem plot, box plot, and histogram, assuming that we are very familiar with other graphs such as pie chart, frequency curve, frequency polygon, etc. In-text question. Frequency table. The first step in examining intelligently a set of data for a single quantitative variable is by constructing a frequency table. This is a tabular arrangement of data into various classes together with their corresponding frequencies. Procedure. Given a set of observation x1, x2 to xn for a single variable, 1. Find the range R, that is, difference between the largest and smallest values of the data. 2. Determine the number of classes k depending on the size of the data. 3. Find the class interval C, that is, range divided by the number of classes. 4. Tally, that is, assign the values to classes. 5. Find the class frequencies. Note, with the advent of computers, all these steps can be accomplished easily. Example 2.1. The following are the scores of 40 students in mathematics test: 50, 08, 14, 20, 46, 23, 26, 47, 32, 31, 48, 40, 49, 40, 41, 38, 51, 86, 55, 82, 56, 72, 60, 98, 59, 76, 55, 80, 52, 63, 57, 67, 53, 70, 69, 63, 65, 66, 22, 27. Construct a frequency table for the above data. Solution is as follows. Range 98 minus 08 is equal to 90. Number of classes is equal to 10. Class interval is equal to range over number of classes. 90 over 10, 9. Study the working table. Class 1 to 10, 11 to 20, 21 to 30, 31 to 40, 41 to 50, 51 to 60, 61 to 70, 71 to 80, 81 to 90, 91 to 100. Tally. Frequency 1, 2, 4, 5, 6, 9, 7, 3, 2, 1. Frequency table. Table 2.2. Score 01 up to 10, 11 up to 20, 21 up to 30, 31 up to 40, 41 up to 50, 51 up to 60, 61 up to 70, 71 up to 80, 81 up to 90, 91 up to 100. Frequency 1, 2, 4, 5, 6, 9, 7, 3, 2, 1. Total frequency 40. Cumulative curve ogive. The graph of the cumulative frequency of a single variable is called an ogive. It is drawn by plotting the cumulative frequency against the upper class boundary of a class interval. On the ogive, it is possible to obtain the median, the quartile, and interquartile range, IQR. Example 2.2. Using the data in example 1, construct the cumulative frequency curve. Solution: Table 2.3. Score: less than 10, 11 up to 20, 21 up to 30, 31 up to 40, 41 up to 50, 51 up to 60, 61 up to 70, 71 up to 80, 81 up to 90, 91 up to 100. Frequency 1, 2, 4, 5, 6, 9, 7, 3, 2, 1. Cumulative frequency 1, 3, 7, 12, 18, 27, 34, 37, 39, 40. Total frequency 40. The diagram shows ogive. Example 2.3. The following data represent the ages in years of people living in a housing estate in Ibadan. Present the above data in a frequency table using a suitable class interval. Solution: maximum value is equal to 69, minimum value is equal to 2, range is equal to 69 minus 2 is equal to 67. A choice of 10 classes will result in some classes with 0 frequencies, while the choice of 6 classes is more reasonable with at least 1 item in each class. In practice, it is easy to determine the number of classes for a given set of data. We are using k is equal to 6 as our number of classes. Class interval is equal to r over k is equal to 67 over 6 is equal to 10.13, approximately 10.0. Table 2.4. It is pertinent to define the columns in the frequency table for better understanding. Class interval is a subdivision of the total range of values which a continuous variable may take. Class frequency is the number of observations of the variate which falls in a given interval, column 3. Relative frequency for a class is the actual frequency of the class divided by total frequency, column 4. Sometimes it is better to work with relative frequencies, especially in the calculation of probability values. Cumulative frequency of a class is the sum of all the frequencies before the class up to and including the frequency of that class, column 5. Relative cumulative frequency: when the relative frequency of a class is expressed as a proportion of total frequency, what we have is called the relative cumulative frequency, column 6. It is sometimes called the distribution function. Box 2.1. Observations from the table. The data have been summarized, and we now have a clearer picture of the distribution of the ages of inhabitants of the estate. Exercise. Simple descriptive analysis of data in tables and diagrams. Data can be presented in the text, in a table, or pictorially. Take 2. Or pictorially as a chart, diagram, or graph. Tables, charts, and graphs should ideally be self-explanatory. The reader should be able to understand them without detailed reference to the text, on the grounds that users may well pick things up from the tables or graphs without reading the whole text. Below are some ways in analyzing data. Histogram. Histogram is a chart used for presenting the frequency distribution of the values of a variable, assuming the variate is a continuous type. A histogram is a group of rectangles drawn above each class interval such that the area of each rectangle is proportional to frequency of the observations falling in the corresponding class interval. The chart is constructed by plotting the values of the variable along the x-axis and the frequencies along the y-axis. Vertical lines are drawn at the lower and upper class boundary of each class up to the frequencies. Horizontal lines representing the width of each class interval are then drawn on top of each vertical line. In a situation where the class intervals are not the same, the height must be adjusted so that the area represents the frequency. Draw the histogram of the data in example 2.2 above. Histogram of ages. Stem plots, stem and leaf plots. In statistics, a stem plot or stem and leaf plot is a graphical display of quantitative data that is similar to a histogram and is useful in visualizing the shape of distribution. It was invented by J. W. Tukey, 1915 to 2000. Stem plots contain more information than do histograms because, unlike in a histogram, where bars are used, the individual data values are displayed in a table-like format in order of increasing magnitude. A basic stem plot contains two columns separated by a vertical line. The left column contains the stems and the right column contains the leaves. Constructing a stem plot. To construct a stem plot, take note of the following steps. 1. The observations must first be sorted in ascending order. 2. It must be determined what the stems will represent and what the leaves will represent. Typically, the leaf contains the last digit of the number and the stem contains all of the other digits. In the case of very large or very small numbers, the data values may be rounded to a particular place value, such as the hundredths place that will be used for the leaves. The remaining digits to the left of the rounded place value are used as the stems. The stem plot is drawn with two columns separated by a vertical line. The stems are listed to the left of the vertical line. It is important that each stem is listed only once and that no numbers are skipped, even if it means that some stems will have no leaves. The leaves are listed in increasing order in a row to the right of each stem. Example 2.4. Present the following data in a stem and leaf plot. 6,866, 72, 75, 76, 106, 54, 57, 56, 63, 59, 66, 68, 64, 8,884, 81. Solution. Table 2.5. Stem 5, 6, 7, 8, 9, 10. Leaf 4, 6, 7, 9, 3, 4, 6, 8, 8, 2, 2, 5, 6, 1, 4, 8. 6. Example 2.5. Given the weight of 20 rams at the end of 2 weeks, feeding on a special diet as follows. Make a stem plot for this data. Solution. The stem plot is given below. Important features. 1. It is easy to locate the center of the distribution, that is, median, is equal to 46. 2. It is also possible to examine the shape of the distribution. Turn the stem plot on its side so that the larger observation falls on the right, e.g., The above distribution is symmetric, just as it is possible to measure the median, first quartile, Q1, the third quartile, Q3, and interquartile range, IQR. 3. It is also possible to look for deviation from the overall shape of the data, e.g., outliers. Back-to-back stem plot. Back-to-back stem plots are used to compare two distributions side by side. This type of double stem plot contains 3 columns, each separated by a vertical line. The center column contains the stems. The first and third columns each contain the leaves of a different distribution. The numbers for the leaves of the distribution in the leftmost column are aligned to the right and are listed in increasing order from right to left. Here is an example of a back-to-back stem plot comparing the distribution of the weight of cow to another distribution weight of ram. Example 2.6. Suppose 20 cows were fed with the same special feed as in example 3. The back-to-back stem plot is shown below. Table 2.6. Observations. 1. Weight of ram is symmetric. 2. Weight of cow is skewed to the right. 3. There is an outlier in the weight of cow, that is 91 kg. Note, stem plot works well for small set of data, especially when the observations are all greater than 0. Box plot. Box and whiskers plot. This is a chart that looks like a box when drawn. They are most useful when comparing two or more sets of sample data. A box plot shows the centers and spread of the data, gives a clear picture of the symmetry of a data set and shows outliers very clearly. It is constructed by first calculating the median, first and third quartiles. In-text question. In the box plot, the ends of the box are at the quartiles so that the length of the box is the interquartile range. The median is marked by a line within the box. The whiskers are the 2 lines outside the box that extends to the smallest and largest observations. Outliers are shown as dots outside the shakers. Example 2.7. Consider the data in example 2.6 above. Construct the box plots. Solution. Diagram 2.3. Box plots. Figure 1.2a, weight of ram. Figure 1.2b, weight of cow. In the box plot, the center, the interquartile range, the spread are immediately apparent. However, the box plot is generally inferior to the stem plot or histogram in that it shows only the center and the partition values. It tells nothing about the shape of the distribution and other values in the data set. A stem plot for large data set provides a clearer display of a single distribution, especially when accompanied by the median and quartile as numerical signpost. Summary. In study section 2, you have learned that 1. It is necessary to present data in tables, charts, and diagrams in order to have a clear understanding of the data. 2. The first step in examining intelligently a set of data for a single quantitative variable is by constructing a frequency table. 3. Frequency table is a tabular arrangement of data into various classes together with their corresponding frequencies. 4. The graph of the cumulative frequency of a single variable is called an OGIF. 5. Data can be presented in the text, in a table, or pictorially as a chart, diagram, or graph. 6. Histogram is a chart used for presenting the frequency distribution of the values of a variable. 7. Stem plot is a graphical display of quantitative data that is useful in visualizing the shape of distribution. 8. Back-to-back stem plots are used to compare two distributions side by side. 9. Box plot is useful when comparing two or more sets of sample data. This is the end of study section 2. Thanks for listening.